Hello, my name is Konstantinos Gabriel. I'm a teacher of physics, and the video you are watching is about the decimal and binary numbers. Let's start our description with the decimal system of numbers. The decimal system of numbers uses number 10 in order to create the numbers, and this is what we are going to explain better and understand better by the explanation of an example. We have the number 52,364 with a base of 10 because it's a decimal number. We are going to see that I can create the 50,000 by multiplying 5 times uh, 10,000 continuously. I can create the 2,000 here by multiplying 2 by 1000. After, I am going to create the 300. 3, it's the position of the hundreds. Okay, so we multiply 3 by 100 and 60. 6, the 6 is the number of in order to create 6, it's 60, 64. So we are going to multiply 6 times 10 plus 4 times 1. So 1, but 1, you must remember that according to the rules of the powers, the number 1 can be created by 10 to the power of 0. Okay, so if I continue now, I'm going to present you the powers of 10. In the place of the number 10,000, I uh, put the 10 to the power of 4. Okay, I have the powers of 10 here now. I substitute 1000 with 10 cubed. I substitute 100 with 10 squared. I substitute 10 with 10 to the power of 1, and I substitute 1 with the power of 10 to the power of 0. Okay, so as you can see, I can create the number 52,364, okay, by using the powers of 10. And this is why we call it decimal system of numbers or denary. Okay, let's go, Tora, now to a conversion from decimal to binary. The binary numbers are numbers that are represented by 0 and 1. They are used in the computer's language. Okay, so I'm going to convert the number 132 point or comma 375, which is a decimal number, to a binary number. First of all, I get 132, that it is the integer part of the this decimal number. And what do? I create this table by writing first of all number 1. After I multiply by 2 and I get 2. 2 times 2, I multiply every number by 2, okay, until I arrive to 128 times 2 gives me 256. Now, because 256 is over 132, I stop. Okay, I have 128, and after, which is under this number, below 132, under this number, it's smaller, this number, than 132, and after, by multiplying by 2, I get 256. So I stop here. Now, I'm going to create 132 by using these numbers. So each time I use one of these numbers, I put number 1 in under its position, its place. Okay, if I don't use a number in order to create 132, I put 0. Now, 256, I'm not going to use it, obviously, because it is over 132. So I put a 0. Now, 128 is lower than 132, so I'm going to use it. Now, how much, what number do I need to add to 128 in order to get 132? I need four more. Okay. In order to arrive from 128 to 132, I need four more. So I'm not going to use 64. I'm not going to use 32. I'm not going to use 16 or 8, but I'm going to use 4 because 128 plus 4 gives me 132. So I'm okay now. I don't need 2 and I not need 1. So the result is 0, 1, 0, 0, 0, 0, 1, 0, 0. This is the representation of 132 in a binary way. Okay, now we are going to continue with the part after the comma, the decimal part. What do? I get 0,375 and I multiply it by 2. Why do I multiply it by 2? Because number 2 is the base of this system of numbers, of the binary number. So I multiply the number after the comma by 2 and I get 0,75. Now what do? I keep the 0 aside. I put it aside here. Okay, and I continue by multiplying again by 2. When am I going to finish these multiplications? When I will not have any more decimal numbers. Now, I get 0,75 multiplied by 2 and I get 1.5. Now, I keep aside number 1 and I use the zero point 0.5. I have kept number 1 and what do I have now? 0.5 and I get 0.5 multiplied by 2 and I get 1. Now I have arrived in a number that does not have any commas after any decimal digits. Okay, I do not have a comma here. Here is an integer number. Okay, so I stop here, 0, 1, 1, okay, which is the part of the decimal number. So the number 132, 375 is written as 0, 1, 0, 0, 0, 0, 1, 0, 0, comma 0, 1, 1 because of this part. Okay, so let's continue now with the conversion of this binary number to a decimal number. What I'm going to do, I'm going to start from the right side of this binary number and I'm going to write the basis of 2 to the to some powers. What powers? I start from the 0 and I continue. 2 to the power of 1, 2 to the power of 2, eh? 0, 1, 2, 3, 4. Okay, I write the numbers as a base of 2 with to the power of the positions 0, 1, 2, 3, 4, 5, 6. These are the numbers here. Okay, so as you can see here, I have some powers to be in red color. Why? Because these are the powers that I'm going to use in order to find the decimal number. And why am I going to use these numbers? Because these numbers, these powers have number 1 as a digit here. Okay, they match, they they match, they are matched to number 1. Okay, because I have number 1 here, I'm going to keep this power. Because I have a 0 here, I'm not going to use this power. So I use the powers 2 to the power of 6, which gives me 64. 2 to the power of 3 or 2 cubed, it's 8. 2 squared is 4 plus 2 to the power of 0, which is 1. So I get 77. And this now is the representation of the binary number to a decimal number. Okay. Now, if I have a binary number with a comma, with decimal, let's say, numbers here, what are we going to do? Now, I'm going to keep this part 0, 1, 1, and I'm going to start from the left side now, from here, okay? And I'm going to use the powers of 2 again. But this time I will not write here 0, okay, as the first, but number 1, 2 to the power of 1, 2 squared here, and 2 cubed here. 1, 2, 3. I start numbering from the left side. 1, 2, 3. And as you can, if you remember, for this part of the number, I have started the numbering from here, from the right side. And I have started from 0. 0, 1, 2, 3. Remember, 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, and so on. But now I have the right side of the decimal uh, digits. I start from number 1 and from the left side. Now I'm going to invert 4 and 8 because this is the numbers I'm going to use, because 1 and 1 are the numbers that create the decimal. Now I am going to have 1 above 4. Be careful, I don't get 4, I get 1 above 4. I invert 4, okay. Also I invert 8, 1 above 8, and what do? I add them. So the sum is 0, comma 25 plus 0, comma 125, so I get 0, comma 375. Okay, and as a result, we get 77,375. So all this binary number is this 77.375. This was a video with decimal and binary numbers and some useful conversions we are going to see in our lessons in our studies. Thank you for watching this video. We are going to continue with some more useful videos like this.